Day 697 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3474, lexicographically smallest generated string. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. You are given two strings str1 and str2 of lengths n and m respectively. A string word of length n plus m minus 1 is defined to be generated by str1 and str2 if it satisfies the following conditions for each index where 0 is less than or equal to I and I is less than or equal to n minus 1. If str1 of I is equal to t, the substring of word with size m starting at index I is equal to str2, i.e. word of I all the way up to I plus n minus 1 is equal to str2. If str1 of I is equal to f, the substring of word with size m starting at index I is not equal to str2, i.e. word of I all the way up to I plus n minus 1 does not equal str2. Return the lexicographically smallest possible string that can be generated by str1 and str2. If no string can be generated, return an empty string. All right, y'all, so I can understand how that may seem a little bit confusing at first. So before we look at these examples, though, let's take a look at these definitions first. It says a substring is a contiguous non-empty sequence of characters within a string. So it's just contiguous, meaning the letters are already next to each other. So this would be a substring, this would be a substring, this would be a substring, etc., etc., right? So it's just a string within a string, or a continuous string within a string, right? So there's no delete sum. It's just it has to be already contiguous in order. Then with lexicographically smaller, let's see what that means. It says a string A is lexicographically smaller than a string B if the first position where A and B differ, string A has a letter that appears earlier in the alphabet than the corresponding letter in B. If the first min A dot length or B dot length characters do not differ, then the shorter string is the lexicographically one. So this is similar to alphabetical order. It's not exactly the same, but for these purposes with a string, it'll be with alphabetical order or the length of the string itself. So now that we understand this problem and the definitions, now let's take a look at these examples. So in example 1, we have our input str1 equals a string tf and str2 equals a string ab. So first, let's break this down, right? So we know we're going to need to find or generate a string where, just a minute. So, right here, n plus m minus 1. So right now this would be n and this would be m. So this has a count of 4. This has a count of 2, right? So 4 plus 2 minus 1 will give us 5. So we know we're going to need 5 characters in our string. So let's just, I'm going to put commas here so y'all can see. But remember, we're dealing with strings, not arrays. And this will be, I'll delete the commas as we go, but we need 5 spaces just so I can show you how this works. So this would be 1 or 5 indexes. I just want y'all to see the indexes. So this would be index 0, 1, 2, 3, 4, 5. Boom. Yeah, I just put in the commas here once again so y'all could see the indexes. It's not necessarily part of the output. I'll delete them at the end so y'all can see what's going on. So this is index 0, index 1, index 2, index 3, index 4, and index 5. Right, we have 5 because 4 plus 2 minus 1 is going to give us 5. So that's where we get this 5 from. Boom. Then, so it says right here, if str is equal to t, then the substring of word with size m starting at index I is equal to str2. So that means right now we're index 0. Boom. So we know that we are going to put this AB starting at index 0, right? So we could put, because this equals a t, so this would be a t at stri, which is, in this case, str of I is 0. So we put, it's a t right here. So we put at index I, starting at index I, we put equal to SR2. SR of 2 is AB. So starting at index I, we'll put an A here at index I, and then we'll put the B here at index 2 because it's starting at index I. Remember, these commas don't matter. I just want y'all to see the index. So we'll put an AB right here, right? So we imagine there's no comma, and we just put an AB right here. Boom. Starting at index I of I, which in this case would be 0. But I'm gonna put that here just until we get done. Boom. So we put the AB here starting at index I. So at the 0, index I in this case for t is 0. So starting at index 0, we put the AB. Then we have another t right here at index 2. Boom. So index 2, this is 0, 1. So at index 2, we start again. We have another t at index 2, so we'll put another A, B starting right there. Boom. And actually, it's an extra one. Sorry, y'all. 0, 1, 2, 3, 4. So it should be, it should be 4 up to index 4, but that's really 5 indexes because we started at 0. So 0, 1, 2, 3, 4. Boom. So now we have this. We have AB starting right here. We have an AB starting right here, index 0, because we have a T at index 0, and then we have a T at index 2. So we also have an AB starting right here, index 2. Boom. Because this AB comes right here from str2. Remember, it says starting at index I, the substring of words starting of word with size M, which starting at index I is equal to str2. So boom, starting at index I, that's equal to str2. Starting at index I right here, boom, this is also equal to str2. Boom. Now, just to make sure, it says when we see an F, so the F, the substring of word with size M starting at index I, does not equal str2. So we have an F at index 1. So starting at index 1 of size M, remember M is 2. Right here, remember size N, M is 2. So starting at index 1, we have a BA. BA does not equal str2, so that works. Then we also have an F right here, right? Boom. And it needs to be of size M. So as you can see right now, this is not of size M. This is only of size 1. We need size M to be 2. So that means over here, we could put anything. As long as this F, it just could not equal str2. So right now we have a B. We could put anything here. We could put an A, we could put another B, we could put a C, we could put a D, we could put an E, we could put an F. As long as it doesn't match this, which it won't match because it's already starting with a B, it'll be good. But we want the lexicographically smallest. And remember, I was talking about alphabetical order. If we put an A here, that is lexicographically smaller than if we put a B here. So we'll put an A right here, and this will be the final output. So that's, and then remember, I told you this is just here. The commas were just there to so y'all could see what the indexes are. And then same with the brackets. Maybe I should have put quotation marks here. But this should match this. Let's line it up and see. Boom, make sure they line up correctly, make sure they match. Boom, y'all, and that's how we got it. So let's take a look at the explanation. Explanation says the same thing. It says the table below represents the string AB, ABA. So first we had a T, so we put the AB. Boom, at index 0. Index 0, we put the AB. Boom. Then at index 1, we had an F. So we put the BA starting at index 1. That's where this BA comes from. Then index 2, we had another T, so it should match AB. So this is index 2, and it matches AB perfectly. Boom. Then F3 equals F. We want the lexicographically smallest, so we put the B, and then we put the A right here to make sure it's the lexicographically smaller. It says the strings AB ABA and ABABB can be generated by str1 and str2, but we return ABABA since it is lexicographically smallest string. Boom, y'all. So just in case that didn't make sense, let's take a look at example 2. Example 2 is a sort of like a trick question where we cannot build the string, right? It says right here, if no string can be generated, return an empty string. So in example 2, we have our str1, our input str1 equals a string tf. This time str2 equals a string abc. The output is a blank string. It says no string that satisfies the conditions can be generated. Now let's take a look at example 3. So in example 3, this is also like a trick question, and I'll show you why. Our input equals a string str1 that equals f, and str2 equals d. The output is just a. So let's break this down before we move on. So since str1 is equal to f, that means since str2 has a size of 1 or a length of 1, right? And then this has a length of 1. 1 plus 1 is 2, but then remember we subtract 1, so that our output is only going to have 1 character. Boom. Since f cannot equal d, we could pick any letter besides D for our output, but since we want the lexicographically smallest one, we got to pick A because that's the lexicographically smallest letter that we can pick when we can only pick one letter, right? And then that one letter we pick cannot be D, but that's why we chose A, because that's the smallest, that's the lexicographically smallest letter possible. So we pick A, and that's why our output is A. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we're going to do is we're going to get the length of str1 and the length of str2. So we're going to come right here, and we'll just say let, open up the parentheses, n, comma, m. We're going to come outside of that, and we're going to set that equal to, open up the parentheses, str1 dot count, comma, str2 dot count. Boom. Then we're going to convert str2 into an array for big O1 indexing. So we'll come underneath this, and we'll say let str2 equal an array, open up the parentheses, and pass in str2. Boom. Then we need to create our result array, which will be initialized with an A, and the final length is going to be our m plus m minus 1 count that we're looking for. So we are going to come underneath this, declare a variable called s, colon, put the, open up the brackets, and we're going to say character, come outside of that, and we are going to set that equal to an array, open up the parentheses, and we're going to say repeating, colon, open up the quotation marks A, then we'll say comma count, colon, n plus m minus 1. Boom. Now we're going to track which position in S are fixed, meaning they're forced by the T constraint. So we'll come underneath this, and we will declare a variable called fixed, and we'll set that equal to an array, open up the parentheses, repeating, colon, square, parentheses A, quotation marks A, comma, count. Oh, excuse me, this time, this will be just a 0. We don't need to put the quotation marks A. Just put a 0. Then we'll say count, colon, n plus m minus 1. Boom. Now, for the first pass, we're going to enforce all T constraints. So if SRT1 of I is equal to T, then the substring starting at I must match STR2. So we'll come right here underneath this, and we will say for, open up the parentheses, I, comma, C, come outside of that, N, STR1 dot enumerated, put the parentheses, where C equals, open up the quotation marks, T, then we'll come outside of that, and open up the brackets. Then we're going to fill positions I to I plus n minus 1 in S with str2. So we're going to say for jn I dot dot less than I plus m. We'll open up the brackets. And if this position was already fixed and conflicts, then it's impossible. So we'll say if fixed square bracket j equals 1, sorry y'all, equals 1, and two and signs, s square bracket j come outside of that does not equal str2 square bracket j minus I, then we could come outside of that and we could just open up the brackets and return a blank string. Then, or else we need to assign the required character, so we'll come underneath this and we'll say s square bracket j, we'll set that equal to str2 square bracket j minus I. Boom. Then we need to mark this position as fixed, so we'll come underneath this and we'll say fixed square bracket j equals, sorry y'all, square bracket j equals 1. Boom. Now, for our second pass, we need to enforce all f constraints. So if srt1 of I is equal to f, then the substring starting at I must not match str2. So we'll come underneath this for loop. We'll say for, open up parentheses, I, comma, C, come outside of that, and we'll say in str1 dot enumerated parentheses where C equals open up the quotation marks F, then we'll come outside of that, we'll open up the brackets, and will be true if we already differ from str2. So we'll declare a variable called flag, and we'll set that equal to false to start. Then we need our position that we can modify if needed, so we'll declare a variable called idx, and we could just set that equal to -1 to start. Boom. Now it's time to traverse this window in reverse. So we're going to say for j and open up the parentheses I dot 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 I plus m minus 1, come outside of that, dot reversed, put the parentheses, we'll open up the brackets, and we're going to check if the current substring already differs from str2. So we'll say if str2 square bracket j minus I, come outside of that, does not equal s square bracket j, then we'll come outside of that and we'll open up the brackets and we'll set flag, say flag equals true. Boom. Now we're going to find a position where we are allowed to modify. So we'll come underneath this and we'll say if idx equals -1 and two and signs fixed square bracket j, come outside of that, equals 0, then open up the brackets and we'll say idx equals j. Boom. Now, if already different, then the constraint is satisfied, so we can continue. So we'll come underneath this and we'll say guard exclamation point flag, else open up the brackets and say continue. Boom. Then if no free position to modify, if there is no free position to modify, then it's also impossible. So we'll come underneath this and we'll say guard idx exclamation point equals 1, so does not equal, or excuse me, -1, does not equal -1, else we can return a blank string. Boom. Now we need to force a difference by changing one character, so we can come underneath this and we can say s square bracket idx, come outside of that, set that equal to, open up the quotation marks and pass in b. And finally, we need to convert our result back into a string. So we could come underneath this and we can say return string open up the parentheses, and pass in S, y'all. That should be all she wrote. Let's give it a run. Make sure it runs properly. It's accepted, so let's go ahead and make sure it's still accepted after we submit it, because we all know how LeetCode can be. Let's see, and look at that, y'all. 58 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.